Okay, to solve for this, since 12 doesn't have a perfect root, you break it down. Get the factors of 12 such that one of the factors has a perfect root. In this case, you rewrite 12 as 4 and 3. Okay, we use these factors because 4 has a perfect root. So since 4 has a perfect root, which is 2, you can take it out of the radical sign. So this becomes now 2 square root of 3. How about this? Square root of x to the power of 9. You have to understand that if the radicand, meaning the expression inside the radical sign, is expressed in exponents, you have to make sure that the exponent is divisible by the index. And the index in this case is 2. So again, we will break down the x power of 9 into x power of 8 times x. X power of 8 is now divisible by the index, which is 2. So again, you can take out x power of 8, bring it outside the radical sign. So this becomes now x power of 4 square root of x. Okay, let's move on to the third example. We have here 18, x power of 7, y to the power of 5. 18, again, doesn't have a perfect root. So look again for factors of 18, that one of its factors has a perfect root, which is 9 and 2. Okay, 18 has another factors which can be expressed in 6 and 3, but then 6 doesn't have a perfect root and this 3 also doesn't have a perfect root, so it doesn't make sense if we will express 18 that way. So instead, we will use 9 and 2. And then as for the x power of 7 and y to the power of 5, both of them again don't have perfect roots. So you break them down as well. So x power of 7 can be expressed into x power of 6 and x. And then as for the y, you express it into y power of 4 and then y. After breaking them down into factors, you now bring out the ones with the perfect roots. For example, for 3, take out 3 now. X power of 6 has a perfect root. Take it out of the radical sign. This becomes now x to the power of 3. And as for the y to the power of 4, again, take it out of the radical sign. This becomes y squared. And then 2xy. You don't bring out 2xy because these don't have perfect roots. And then lastly, you have cube root of 24, x power of 5, y power of 8. As for the 24, again, 24 doesn't have a perfect cube root. So you look for a number that can divide 24, of which that number is, or that number has a cube root. So again, express 24 into 8 and 3. Because 8 times 3 is equals to 24, and 8 has a cube root. So that's why you have to express 24 as factors of 8 and 3. And then, as to the x to the power of 5, express that in such a way that its exponents is divisible by the index, which is 3. So instead of x power of 5, express it as x power of 3 and x squared. As for the y, express it as y power of 6 and then y squared. Okay. So now we can take out the 8, which is 2, since the cube root of 8 is 2. And then take out x cubed as well. Cube root of x cubed now becomes x. Because all you need to do, again, when it involves exponents, you just have to divide the exponent by the index. And then lastly, you have y to the power of 2. and then you have the radicand as 3x squared y squared. That's the final answer. That's all.